Hello, welcome to Art by Data Science. In this tutorial, I would like to continue from what we have stopped last time. So this would be a continuation of the text mining tutorial that we have done in the past. So if you haven't watched my previous tutorials on text mining, we have this series of text mining and actually supervised text classification, mainly from biomedical literature data that we are going through. So I do recommend to watch the previous tutorials. Otherwise, you can also start. You can also just start from here. I mean, from this video and continue the rest of the class if you are familiar with how to read bibliometrics, bibtext data, reference data in R, and how to do some basic bibliometric analysis and all the clustering and some of the previous word cloud, and Sankey plots and cluster plots. We have also done some really Unigram text analysis using Unigrams, and we have plotted some bar charts and word clouds. So if you are familiar with it, you can also continue from here. But I do recommend watching these tutorials. Having said this, we can go. I can directly go to our data. So our data, as I said, I have already put it in our in the link in the previous tutorials. I put where you can get the data. This is the bibtext data. So we'll just run the URL, and then later we will read it using this bib2df library. So let me load that bib2df library, and then from there we can directly read our bibtext file. Then it's about COVID, as I said. It's COVID publications mainly. Yeah, so we are doing some reading, and this is just repetition of what we have already done in the previous tutorial. So let me just go through, and then we can go directly with our text analysis. So the first one is we are selecting title, abstract, keyword, and author. These are just the variables that we are interested in. If you remember from from previous tutorial, we have I have shown you how this data look like. So it has some category and bibtext key. This is just the key, and the address, the anode, and it's basically 32 different variables, but we are not interested in all of this. We are simply interested in doing text analysis using just the abstracts. So we are only interested in boiling this down and do some analysis to find out some patterns, relationships, and also looking at some most common words and the like. That's what we are interested in. So probably let me do one more thing. Let me just, instead of using abstract, I can use both title and abstract, but we can simply replace, because if you look at these references, so you have the title and the abstract. So that's I do believe the terms that are included, I mean the words that are used to write the title, they are also part of the abstract. But in some cases, at least in my experience, I have noticed that if you add the title and the abstract together, and if you do your text analysis based on the two instead of one over the other, then you could probably, if you are training machine learning models or something, then it's I do recommend combining the two. And it's not always, but there are times that the words that are present in the abstract are not part of the title, or the title words that are present in the title, they are not part of the abstract. So probably it's nicer if you combine the two, especially if you are doing some text classification task. Otherwise, for just practicing, we may not need to combine the two and just focus on using abstracts. So that's it. And then the next thing that we need is we need to load the tidytext. The tidytext. So if you remember, we have done some bigrams, unigrams, actually using unigrams. Unigram is just one word token, but if you use bigrams, that means it's a combination of two words. So in my previous example, I have shown some examples, if you remember, something like so it's like this. If you do trigram, it will be like the new pandemic. This is COVID is a new viral disease. So if you do bigram, so COVID will be one column or one variable, and then is a will be considered as another variable, and then it goes a new will be considered again another column. So that's what bigram is actually. So if you make it trigram, then you mean that you are using 3 sequence of variables. So instead of one word, you use 3. That's trigram. But going further, going more than trigram, probably it's not really useful, especially in improving the performance of prediction performance of your machine learning models. So it's better to just focus with bigram and unigram, because there is already there would be high correlation between there will be high correlation between one trigram over the other, because there will be one word which is part of the other bigram, and then it goes to the other, because as I said, this word COVID is, and again this is will be again to the next. So there would be a high correlation, which will possibly affect your machine learning models. So to do the type unigram, this is what you need. So if you use tidy COVID, as I said, I use tidy text. So you use tidy COVID, and COVID data, you pipe it. That's the data, and then you give it the input. That's the text data that we want to pipe, to go through, and then the output will be unigram. That means just one word. So if we run this, we can have unigram text, but we just don't want to use we don't want to do unigram, because we have already done it in the past in my previous tutorial. So I just want to do another one, the trigram, the bigram. Trigram or bigram, it has the same analysis structure. So what you need, I can just go down, because we have already done the other ones. So this is what we need for the trigram. I can also show you here. So these are you can simply check what are the contents of the unless token. It's the same code that you use for Unigram. So we can define our data. We give it, let me call it tidy COVID, and then we use unless token. Then you use COVID data, and then the type of Unigram is bigram, and you can give it token equals Unigram, and that's the text data that you want to go through, n equals 2, and that should be enough to give you the. But you can also use the other ones like true, I believe they are by default true, but like you can change all the text data into lore, so then there will not be let's say if one is written like this and the other one one is written like COVID and another text word could be written as COVID. In fact, they are similar, but computers will not understand that they are similar. So you need to change them into lowercase. That means they need to be changed into lowercase letters, small letters. So then they will be counted as similar word or as one word. So this is I believe that's by default true. That's actually by default true. So you don't need to define it. But if you don't want to lower them, then you obviously will have to count them. I believe this is rather very important. So you don't have to define it as false. So the default is true. So you don't need to do anything. And then that's all. We simply run it. And let me just run. It it seems I have some error. So it says if collapse equals true, such as for unnesting by sentence or paragraph. Okay, unnest tokens need all input. I believe this is what we need. Collapse equals true, but we need to define it as false because that's the, I think by default this is null, but let me see what collapse. Whether to combine text with new lines first in case tokens such as sentence or paragraph span multiple lines. Okay, because we have multiple lines in abstract, so that means we need to use this collapse argument. So we will define it as false instead, because it's true, the default is true, that's why it's complaining and it's not doing our bigram analysis. So let's run this, and now it's yeah, it's already run. So if you remember, our in our Unigram, this was about I believe it was about 60 something thousand or 45,000. I don't exactly remember, but we can also run it again by giving it a different name. Tidy COVID, let's say Unigram, let me call it. And then this is how you do Unigram, and then let's see. Okay, so this the bigram looks a little bit bigger. So we have about 79,786 bigrams, while the unigram is about 79,404. So this is something to do with, you know, high dimensionality, or the curse of high dimensionality, which is which may be very important if you are doing really text classification. So we can have a look how these are the text data we have, and then at the end we will have the bigram. For example, this is bigram. So this study has two goals. Yeah, these are how these bigrams are structured. But as you see, we have these stop words that we may have to remove. These are the stop words, the not relevant words, unless you are doing some grammatical, you know, grammar research. Otherwise, these words by any means change the meaning of, you know, the meaning of the abstract, or the abstract that we are dealing with. For example, these guys are talking about air pollution, so we don't have to the and to or whatever number, I mean whatever kind of word, this stop word will not change the meaning of the I mean the meaning of this concept. So let me go down again. So as you see, the bigram we have seen and the unigrams, they are like this. Now these are unigrams, these are bigrams. No, okay, probably this is unigram. Yeah, these are unigrams. So this study has two goals. The first is to explain. So it's just you know, this, yeah, it's deconstructing the whole paragraph into tokens. That's what unigram or bigram is. Yeah. So the next one that we need is we need to remove stop words. These are not really don't need them, so we have to remove them. Maybe we can do some investigation to look at what are the most common words or something. We can count them, and for that what you need is let me have a look, this COVID, tidy COVID, and then let me pipe it. Then you count as we did last time. So we count it, count this tidy COVID, we count what? We count bigrams. So we have to count this word, or if you are dealing with bigrams, then you count the bigrams. Not this one here. So you count, not again here. So let me open the bigrams. This is not. bigram. Okay, this is bigram then. Yeah, this is bigram. So we count how many times any word has appeared, so that we count them. So to do the count, we mention the data, that's tidy COVID, and then we count them. What do we count? This word or this column or bigram. So I will give it bigram, and then we sort it. We sort it descending order, like from the most common ones to the other. I mean, if you do this, it will count. Let me, you can save it as a new data, or you can have a look the most common ones. Let's say head, that means it will display the five or six actually, the top six most common words. So that's what this does for you. So head, it's now counting. It will take a little bit of time because it's going through all of them. Now it shows you COVID-19 has happened 989 times, and this useless English word, it happened 571 times. But SARS-CoV is also another most common word, and it goes on and on. But if you want, you can also take 10 most common ones. That's also possible. So it define the 10 most common words. So you can put this in word cloud or in bar chart or in network graph or whatever. So that's what we are going to do today. So the first, again, so as you see, there are many useless words that we will not change the semantic structure or the meaning of the text. So we will have to remove these words. So we need to remove these useless words. They are called stop words actually. They are important for grammar, but they are not important in changing the meaning of the text. So for that we need tidyr package because we want to use this filtering, and then what we call our data is tidy COVID bigram. So we call that data. Actually, let me call it separate because we want to separate the bigrams, because unless we separate, we cannot easily remove the stop words. So first we have to separate these bigrams, this and study. So we will have to separate them like word 1, word 2, and then we will combine them again. So to do that, first you need again tidy COVID. We pipe it and separate. We need to use this separate function from I think from this tidyr. Then what are we going to separate? We are going to separate the bigrams. How do we separate them? We label them as the first one as word 1 and the second one as word 2 and then we give it a separator. How are we going to separate the two? We are separating them by just a space. Yeah, that's what we need. Can do that. Could not find function separate. Yeah, we need to load the library tidyr first, then we can have access to this separate function. Now tidy COVID separate, maybe we can have access to that. Where is it? Tidy COVID separate. Maybe we can see. Yeah, that's it. Tidy COVID separate. So you have word 1 is study. It was this study, but we separated. So this and then study. We have separated the two. Once you separate, then you will be able to remove stop words. Again, tidy COVID separate, and we call it again, and we pipe it. Then we use filter, and then we say word 1. That's because we want to remove stop words from word 1. That word 1 is here. So we have to remove all these stop words in word 1, and again we have to remove stop words from word 2. So for that you need to use word 1 and this sign percent in percent and then stop words. It should be stop words, then you use this word. So that's it, that's what you need. Now that means with this code we will be able to remove all stop words in word 1. The next one we have to use word 2. That's what we need. Then you pipe it, then you change this word 1 into word 2 because we want to remove all these stop words in word 1 and word 2. That's all. Then we run it. Remember we have about this much number of this word is tidy COVID separate 79,786. If we remove this stop words, this number should be much lower than the one we have here. So we run this. Now it should be this one. No, let me see again. Yeah. So now all the all the stop words, they are all removed. You remember there was like this study is or something a. They are all they are all gone. Maybe we can have a look at the dimension of this data, so then we can have access to, we can see how much big this, how many rows do we have. Then we have like, yeah, that's 23,747. That's from 700 something thousand, which is which really has declined it, yeah, in a much lower number. And now what we need, we can do the same. If you remember, we were counting them, then we count them this way. Maybe we may have to, okay, let's start doing the same and see. Actually, before that we need to join them to make them bigram. So we need to yeah, let's ignore this because otherwise it will not count it unless we join them. We have to join them again. These words, we need to join them again. We need to join them and make them together. Otherwise we cannot easily count them. Anyway, let me say count. Maybe we can COVID bigram counts. COVID bigram counts, and let me say COVID separate, tidy COVID separate. We can use this data and then we pipe it. Then once we have that, we count word 1, word 1 and word 2. Word 2, we count them. Once we count them, we can see the most common word is like the top most common or something. So to tidy with separate and count word 1 and word 2. Yeah, so we have the counts. So let me say the head. We can see the top 6. So these are the counts actually, how they look like. Okay, we need to sort it actually. Sorry, I forgot something because these are simply not sorted. These are simply not random actually. It starts from the first observation. Instead, we need to sort it so that we can have access to the most common words on the top. So now if we sort it, so we see the most common words. So COVID and 19, it happened 989 times, and SARS and CoV together as two words, they happen 443 times, and CoV2 it happened 401 times, and it goes on and on. It continue until the last word with 0 and 1. So anyway, as you can see from the dim call, if you remember from the dim call, we have seen the tokenization process changed the abstract of these 382 documents into 23,747 bigrams. So the next thing we need to do is we need to join them. We have counted them, we have seen, but we have to join them. We need to join them. To join them, again, maybe let me call this, instead of separate, tidy COVID united. Maybe I can call it like that. United, and then I can simply call my previous data, which is this tidy COVID separate, and then once you have that, we use this unite function. Unite, we call it bigram, and then we give it word 1 and word 2, and then we use separator, and that separator is just space, just one space. Yeah. So tidy COVID united, tidy COVID separate, and then we call it bigram. And what are we joining? We are joining word 1 and word 2. So we unite them. Now we can have a look. Tidy COVID united. I am not sure. Maybe it is one, I believe. Yeah. So now they are joined. So you see join environmental determinants, and then it goes on and on. Now we can count them again. So if you remember, we count here. We did some counting. So let's do this, and then we call our head function. Head. Instead, I will do this tidy bigrams united. I'll just and then what I need is, because I have bigrams, so I call this bigram. If you remember, we have this in the united, and then we call this our head function, and then we can simply say, I don't know, 10 for example. We can simply count the 10 of them, and then see. Yeah, so we have, these are the 10 most common bigrams that happen in our text, and COVID-19 is obviously the most common one, which happened 989 times, and then it goes down like this. So we can, we can create a data, and then we can use ggplot2 or whatever, and then we can use, we can use ggplot2, and then we can plot them in bar graph, or you can also use word cloud again, to plot them in a nice plot. Yep. Now see, the next thing is we can visualize them. Actually, visualization is the most interesting part of text analysis. It takes because you want to see the text. So the text, at least you want to see what are the most common words and how are they related to each other and the like. And that's usually done. If you are interested in relationship, then you need to do network diagrams. But if you are interested in seeing like frequent words or something, then you probably need to do word cloud or charts. So as we did last time for word cloud, what you need is word cloud package. We have word cloud. Thankfully, people have already written a nice package for us. So we define our word cloud, and then we define our color brewer. This is exactly how it's written in the package. So you just use brewer pal, and we use 8 labels, and then we start with dark 2. Then what you need is you start using your data to plot your bigrams. So you start tidy COVID united, that's the data we have. You pipe it, and count the bigram. You count the bigram, and again you pipe it. That's how you define your data. And then you use with function. With what? With word cloud. With word cloud. And what are we plotting? Bigrams. We are plotting bigrams, and what number of times that the bigram is mentioned, and how many times maximum words. And that's let's do 150 maybe, if that's enough. And the color palettes, maybe I put it below here, maybe for readability it's more easy. And that's the last one is left, colors, because we just need to define the color. We have already defined it above, pal, if you remember. Now everything is set, so we will have a nice looking word cloud. Now it will take a little bit of time. Yeah, then it will. Yeah, there are some ignorable errors here. It's mainly because the word cloud is not big enough to fit 150 words. Yeah, because we want to fit 150 words, and the bigram it's written in a long text, so it might not be it might not be fitting in our. Okay, let me see. It's already done. So if you see, these are the bigrams that we have. So it's like angiotensin and CoV-2 syndrome, coronavirus, and the like. But probably we can also have more words. You can change the structure into circle or something, the shape. I believe there is maybe let me change it to 200, so we can plot more words, but I don't think it will fit because the words are longer, so they will not fit in the plot. So you see it in real time while the words are being added in the plot. So severe acute, something seems not working, especially our color brewer, because I expected the colors to change, but it doesn't seem to have changed it. So brewer pal, maybe I have some error here, I don't know. brewer pal with word cloud bigram, count bigram with word cloud bigram, and maximum words 200, colors. It's not, I don't know, something seems to be wrong, but the colors are not changed. But I need to have a look more colors. Yeah, in this case it's working, but it's showing only one, but I want it more to show more colors. Yeah, well, this doesn't seem to have worked. Anyway, we go further to our network diagrams. So now we have already seen how these bigrams are joined, how they are separated, how they are counted, and how they are plotted. Maybe we can also plot them in bar graphs. So probably to do that, what you need is you can simply copy this part of the code. And okay, count bigram. Because that's our data, and then we use ggplot2, and what we need is we need to define our aesthetic mapping, just like what we did actually in the Unigram. So we aesthetic mapping, what we need is x is the word and y is n, that's the number of times the bigram was mentioned. Then at the end we define our geom function, which is geom call, and let me define fill that's the color that we need, and then let me give it dark green, and then we flip the port, like the structure of the the orientation of the plot. So we change the y-axis into x-axis and the x-axis into the y-axis. This is so if you do this, you will have a really large plot because it's plotting all of them from 989, from the word that happened and that was mentioned 989 times to the last one, which was mentioned only once. Yeah, so what we need is we need to filter. So once we count them, we need to filter the most common ones, and that's n. You can use like top n, or maybe filter n greater than 50, or maybe 100 if you want. You can do the most common ones. Actually, the number of times, this is the number. You can use top n, which is like top n. I think top n works in R. Top n, so you can use top n means like something, the most common ones, top n, and then you in bracket you say 100 or 50 or something. And this one is just filter n greater than 100, is because we count them and all of them have n value, and that's we are telling it to plot words that were mentioned more than 100 times. Then we pipe it. Now we should be able to find our bar graph. Let me run this. Hopefully I will not have an error. So there seems, this is bigram, not word. Sorry. Now it should work. Unknown color name, dark green. Wow, green. Yeah. Well, these are not really many words. Okay, so we can change it maybe 50, and we have more. So let me run this. Yeah, these are the most the words that were mentioned more than 50 times. But we can do something. As you see, the plot doesn't look nice because you have to do something like reordering. So to reorder, I think what we need is like we need to mutate bigram equals reorder. That's exactly how you actually reorder bar chart. So we can reorder the bigrams by n. Reorder bigram by n, and then we pipe it to the rest of our function. So this plot, this should be somewhere at the top, and the least common one should appear down here. I think this should work. Yeah, now it's changed. You see, it's reversing the order. Maybe if we can also do I don't know, 30 times, then this plot will be really large. I expect it to be large. Okay, let's just stay with 50. So now let's say if you have some characteristics, let's say some kind of character. I mean, in our data we don't have like a stratify. If you find some stratification within this data, then you can create a color variable, and then you can have two strata. Otherwise, these are the most common unigrams, and this is how you display it in ggplot bar graph. The next one probably would be network graph. If you want to see how these bigrams are related to each other, then it might be interesting to look at network graphs. Actually, network graphs, they are they are important in text analysis, because in text it's like words are networked to each other. One word is connected to the other, so network graphs are probably more powerful than I don't know, things like bar graph or word cloud or the like. So to do the network graph, what we need is we have a nice package called igraph. That's what we need, and then ggplot2, of course. Then what we simply to plot is we need to plot the network. First, we need to plot the network. So first, the network can be the network data. We need to create the network data. So let me call it bigram graph, and the data we have is tidy COVID United, and we pipe it again, and then we filter where n, I don't know, greater than, probably we can use 20, so then we can have a large network. Then we pipe it again, and then graph. I think they have this graph from maybe I have to load this package first, so then I can have access to the functions. Otherwise, I don't have access. I don't know how that graph from data frame. I think that's what we need. Then this will create the data frame that we need. Bigram graph tidy COVID data united filter n greater than 20 graph from data frame. Yeah, then we can create the network. Something seems to be wrong. So filter, problem with filter, input n, comparison is possible, only atomic. Okay. Graph from data frame. Okay, we need to count it first. Okay, we have to count it. So this is problem with filter for atomic. I believe we have to count it first, because we are filtering, so we have to count bigrams actually. We have to count bigrams, and similar to the one we did actually in the previous section. So we have to count them first, otherwise we will not have access to we cannot filter n, because n doesn't exist unless we count it. So let me run this. This should work now, I believe. Yeah, it's not working. So this is the kind of data we have. So it's this is something that you might not be interested in going further, because this is how the network graph needs the data to be arranged in. Then we have our bigram graph data. The next thing is we can plot them using gggraph library. So we can plot our library, that's gggraph, gggraph, I think. Not gggraph, we are used to this ggplot2 gg, so it's gggraph instead. So we need to set it, so then we have to reproduce it. So you can use simply 1, 2, 3 to reproduce your or whatever, 2019, just to replace, or 2021, whatever kind of number. It's just to reproduce the network graph you want. So then it has to be reproduced again. That's just for reproducing it. So once we have that, we call, let me load the library, and then we call our gggraph function. Gggraph, what this gggraph needs is a graph database data frame, and you define the layout. Our graph data frame is bigram graph, and then I define the layout. The layout could be There are many different layouts, but you can kind of choose gggraph. Gggraph. Okay, and you can see what kind of layout actually it does. So the layout can be auto. Maybe you can have a look. So the layout is it's either a function, a matrix, or a data. But you can see auto or I think one of the one of the things that I remember is FR or auto. I think it's better to advise to have a closer look of this network gggraph package if you are interested in more network graphs. Then it's I think we use this geom edge link. Where is this geom edge link? It seems it doesn't exist, but geom edge link, what it does is this geom draws changes the simplest as a straight line between the start and the nodes. It plots the lines, between the start of the word and where that word, where the next destination point. So that's we just need that. And the next one would be another one, geom node point. And this geom is most useful together with the fabric layout for showing the horizontal span of each node. Yeah. Then we plus again, and we go for another one. That's geom node, I think. Geom node text. And this one are equivalent in functionality to ggplot to geom text. Actually, this replaces geom text. That allows simple annotation. It's just to annotate the text in your network graph. You can label them as a text label. So you can use the same. It needs aesthetic mapping. The label should be name, and you can use additional arguments like vjust, maybe vertical justify, and then horizontal justify. That's one. And now it should be ready to plot our network graph. So let me reproduce. Let me set the seed for reproducibility, and then yeah, so lala. It's nice network graph. Maybe I need to wait until this is. Yep. You can color it, I believe, make it more attractive. Actually, so if we extend this, you can see how words are related to each other. So you see, let's say in this case, you have MERS code, air quality, outbreak, patients. I mean, you see there are lots of numbers, so we can also consider removing numbers in your text analysis, and otherwise it might be, but for some of the cases, let's say if you are doing some genetic analysis or something, then you may need to keep the numbers. But in this case, we may not need the numbers. But we can also make this plot a little bit larger by choosing filter more than 10 times words that happen to be that occur more than 10 times, then this will be a little bit dense. Maybe let me do it 5, and this will be a lot denser. Then yeah, so this will be a bit larger. So then that's how it looks like. There are words that have a strong relationship with other words. The center of the word is somewhere here, but still it's going one from the other. Maybe we can do instead of 20, so we tried 5, maybe we try 15 and see how large this graph. When it's dense, it may not be interpretable actually, because you don't see the text. Probably this was okay, this is okay. So you see how these bigrams, how this word is one word with the other are related to each other. So you can probably, I mean, if you have a text that is really interconnected to each other, then you may actually be able to formulate the paragraph using this, using just this network graph. Maybe if I do 10 and again, okay, with 10, still this one is nicer. So 10 seems to be okay. So there is somewhere COVID here, COVID. So there is, it's related with pulmonary and viral infection, respiratory tract, cross-sectional current, yeah, all this pneumonia, and because all the terms that are directly connected with COVID, and that's what is showing. And there is some useless word, textless. I believe this is some non-alphanumeric character. So if you have something like this, you need to deal with this. Let's say you need to filter out this textless word. So otherwise, this doesn't give any sense to appear in your graph. And also, if you are reporting like this kind of text analysis, I suggest to remove all the numbers, because removing numbers is one of the things that you need to do besides removing stop words or changing your text to lower characters and the like. That's how the network graph looks like. You can stratify it based on your if you have text data. Let's say if you are working in a sentiment analysis, for example, if you have positive and negative sentiment, so you can stratify this network graph by negative and positive sentiment, and you can see the words how they are related to each other in positive and negative sentiment. You can kind of stratify it. Otherwise, you can change the colors, I believe, but I am just looking at directly the network package. This is a really nice package. I personally like it, but I haven't used it much. Yeah, I think that's what I want to do for today. For the next one, I will jump into Contida, which is a more interesting text mining package. Actually, it has also an inbuilt machine learning package. So I will proceed further in it. Till next time, you can continue following this channel or liking it, sharing it, and keep subscribing, and let others know to come to join this channel. Thank you very much.